Hi there, folks. Root Beer here, looking at C2 on our 2017 open paper. A function f, or f of x, is periodic with period t greater than 0 if f of x plus t is equal to f of x for all x. The smallest such number t is called the least period. For example, the functions sine and cosine are periodic with least period 2 pi. This is true. Tan, which you might remember sort of looks like this, tan repeats every pi and would have least period pi. So we've got three parts of the question. I assume they all deal with least period. A, let a function g of x be periodic with least period t equals pi. Determine the least period of g of x over 3. So you might want to be calling this maybe a function, little h of x. I see later on they're going to have a capital H of x, but you might want to give that a new name just so that you can talk about it. And you might want to have S be your new least period or something like that. Okay, so what can we say? Let's actually write that down. Let h of x equal g of x over 3. Then h of x has a period of s exactly if h of x equals h of x plus s for all x. That's fine. But now we can change things. We can say now g of x over 3 equals g of x plus s over 3 for all x. And then we can say, okay, well, g of x over 3 is equal to g of x over 3 plus s over 3 for all x. But this is true. We could even say, if you really wanted to, you could say for any x we can find a y so that x is equal to 3y or something like that. But I'm confident just saying, well, this is true if g has s over 3 as a period. Okay? So we get this nice sort of back and forth between, a period for this function gives you a period for this function. And so we want the least period s. Well, the least period s should correspond to the least period for g. Or not the least period of s, the least period of h equal to s. Should correspond to this least period of g, which is equal to t. And so s over 3 should be equal to t. Okay? So you want t to be equal to s over 3, but pi is what we're told is equal to t, so s is 3 pi. So that's our least period. Okay? Alright, not so bad, not so bad. And so we'll move on to B part. Determine the least period of h of x equal to sine of 8 plus x plus cosine 4x. Okay, so we got sine x and cos x. We were told they have a least period of 2 pi. Now you might notice in the last question and this one, if f of x has least period t, then you can actually show this. If you're familiar with periods, this is a fairly common result. That this is true. If you know the least period for f of x and you change to a new function just by multiplying x by a constant positive value, you'd have to throw absolute value bars around this if k wasn't constant. But you can get the least period for this modified function. So you can say things like sine of 8x has least period. We were told it's 2 pi, so 2 pi over 8, which is pi by 4. And cosine 4x has least period 2 pi by, well, we multiplied by 4 inside the function. So this would be pi by 2. Okay, but you might say, well, they're not asking about sine 8x. They're not asking about cos 4x. They're asking about a combination of the two. Okay, so here's another nice period-based fact. If f of x has least period t, and g of x has least period s, then it'll turn out that f of x plus g of x has least period, and then you use the lowest common multiple of these two, integer multiples. So, has a least period of, let's call it u, if there are integers. These guys are positive, so if there are positive integers, a and b. So I can actually knock off this least period stuff. This is just true of all periods, really. So that u is equal to at plus bs. Oh, sorry. U is equal to at is equal to bs. Okay? So how do I know that would work? Well, look at f of x plus g of x. I know that if I add on any number of integer multiples of t, I get the same f of x. I get the same value for f. And if I add on any integer multiples of s, I'll get the same value for g of x, because the period doesn't really change the value. It's like shifting the function along the x-axis, and it just sort of syncs up with itself. But, of course, this is f of x plus u, and this is g of x plus u, based on our conditions on u. And this is sort of, you can show this is sort of the only way that this is going to happen. So the least period of a combined sum of two functions is the, now I'm going to say lowest common multiple. It's unusual to see lowest common multiple written when, admittedly, the t and the s, they could be non-integers. T and s. So in this case, with sine and cosine, we're talking about pi's. But it's entirely possible that this exists only if, say, s over t is rational. Okay? If not, then adding the functions will never sync up. And it doesn't work that way. Okay? So we know that, what was it? Sine 8x, it was pi by 4. Cos 4x, pi by 2. But, of course, this is 2 times pi by 4. So and this is 1 times pi by 2. So lowest common multiple is pi by 2. Therefore, pi by 2 is the least period. All right. So that was B part. A little explanation, a little bit of extra theory. Now, if you've seen periods before, this is nothing new to you. If you haven't seen periods before, this would be not the easiest thing to deduce on the fly, but you can do similar work to what we did back here, and you can come up with these rules on your own as well. It just takes a little bit more experimentation. Okay, this is why seeing lots of different varieties of math. I first learned about periods when I learned trigonometry with sines and cosines and tangents. But seeing lots of different math can help, build up your knowledge base and make questions like this go faster. Okay, so C. Determine the least periods of each of g of x and f of x, where g is sine of cos and f is cos of sine. Okay. So, well, let's think about this. So g of x is, which one was it? Sine of cos? Yeah, sine of cos. Sine of cos. Now, I want to just talk about any period for a moment, and then we'll start deducing about the least period. Okay. Now, I might have a strong urge to make this equal to cos x, and therefore the t is going to be 2 pi. But let's think about this for a moment. There are properties of sine and cos that we might need to use. So let's, I'm going to expand this out and say this should be cosine x cosine t plus sine x sine t. Wait, hold on. Is that formula correct? If I had if x were 0, we'd want cos t as our answer. And that seems to work. If x were pi, or no, if x were, say, pi by 2, I'd get sine t, but it's not the case. So I need a minus sign. It's important to try and be able. It'd be really nice if I had these things memorized. I don't run into them all the time. Okay, so I like that I'm seeing a cosine x here. That's good. I don't want to see a minus sine x. And you might say, well, gee, maybe there's a t, so that cos x, cos t minus sine x, sine t can make everything work out. But if you try that, you're going to wind up realizing that, no, there's just going to be an extra sine x in there that is going to absolutely mess up your day. Okay? So we need to get rid of that sine x. How can we do that? Well, we need to multiply by 0. We've got a sine t sitting there. So we need sine t to be 0. Okay, very nice, very neat. Okay, you could try and set up something like this. We need cos x to be cos x, cos t, or something like that. But it's easier just to say, well, sine t should be 0. Okay. So sine t has got to be 0. Well, when does that happen? Well, that could be t is 0, except that's not a positive value. T could be pi by 2. No, not pi by 2. That would be sine of t is 1. We could have pi. We could have 2 pi. Okay. So you'll notice this pi is creeping in, even though the least period of sine is 2t. We're not so interested in that. We just want to know when is sine 0, and that happens a bunch of times. Really, any positive multiple of pi will do the trick. Now, the least of these is going to be pi. We can check sine of cos x. What's cosine of pi? So that'll make the rest of this go away. Now, cosine of pi is minus 1. So we'll get minus cos of x. Now, sine is an odd function, so the minus sign pops out. And this isn't quite what we want. It isn't quite what we started with, so oops, this isn't going to work. So pi doesn't work. Let's try 2 pi. Okay, so what if t is 2 pi? We're just going up the list because we're trying to find the least period. So we'd have sine of cos x cos 2 pi, and then the rest goes to 0 but because of our choice of t. Cos 2 pi is 1. So we have exactly what we need. Okay? So pi was almost in there, but because sine is odd, it's not going to work. I suspect for the next one we might get something similar and pi will work. But you could sort of realize that you're going to have at least 2 pi. 2 pi is the upper bound because sine and cosine both repeat with 2 pi. But, alright, so for, what do they call that one? G of x? Yeah, for g of x, 2 pi is least period. Alright, what about f of x? So that's things switched around. That's the cosine of sine. And we're once again going to look at x plus t. And we're going to have sine of x plus t, so we'll expand that out. So sine of x cos of t plus sine of t cos of x. And so just as before, we really don't like seeing this cos x here. We want to get rid of it. So we want sine of t to go away. Well, we remark that so they know that we know what we're talking about. We need sine t to be equal to 0. So t is 0, not going to work. Pi, 2 pi, you could list 3 pi. We know one of these two is going to work. 2 pi definitely is a period. It's just a question of, is pi a better period? That's all that we have left to show. Okay, well, cosine of sine of x cos pi, plus it'll be 0, is equal to, and we saw this last time, we get a minus sign here. But sine is what we call cosine is what we call an even function. And so minus signs go away. You may have seen this before. Cos of x is the same as cos of minus x. So this is cos of sine x. And it turns out pi does the trick quite nicely. So f of x has a least period of pi. There we go. We have 2 pi for g of x, but the stars align for us, and f of x gets pi. And that was all we needed to show. So we're done C2. Up next, of course, will be C3. Thank you guys so much for watching. Feel free to drop a like or subscribe if you want to be kept up to date on more open papers or other math contests. And if you had a different way to approach the problem, I would love to hear it down below. But either way, I hope you all have a wonderful day, and I'll see you for more math next time.